All right, in this module, we're going to go over an example problem of the lever rule. So just like all of our other example problems, I'm going to have you do this one in the quiz on Canvas. So after I read through the instructions, head over there, fill out the problem, and come back and we'll work this out together. But first, what I want you to do with this is, again, we're using that same isomorphous copper-nickel phase diagram, and I want you to determine the weight fractions of the phase or phases for 2 points. One is 40 weight percent nickel and 1300 Celsius, and the other is the same composition, 40 weight percent nickel and 1250 Celsius. So determine the weight fractions of the phase or phases that are present at those 2 points. So go ahead and do that, and then come back and we'll work this one together on the paper. All right, so let's go ahead and look at determining the weight fractions of these phases at these 2 specific points. So both of these are at 40 weight percent. So I'm going to draw that line approximately. Right, that's 40 weight percent nickel. And then the first temperature is 1300. And the next one is 1250. So I'll go ahead and draw that one too. All right, so you can see that the first temperature and composition are up in the liquid, as always, and then liquid plus alpha and alpha. So the first one is in the liquid phase field, and so this one's going to have 100% liquid, so that's my phase amount too. So my weight fraction of liquid is 1 or 100%. Then that means that the amount of alpha is 0 or 0%, right? Because we have 100% liquid, so all of it's liquid, none of it's alpha. However, at the lower temperature of 1250, we see that we are in that 2-phase field. So we're going to need to apply the lever rule in this case. And so I draw my tie line first, and I have my endpoints. So this is C liquid, this is C alpha, and then this is obviously C naught. And if we want to label them just like we did before, we can call this distance R and this distance S, right? So we've got everything set up now. So if I want to start with the liquid, right, from the previous, what we talked about, liquid, which is over here, we're going to use the opposite length, which is S. So we're going to take S over R plus S. And then the weight percent alpha is therefore going to be the opposite. So we're going to take the opposite R over R plus S. So all we need to do now is put numbers behind this. And so let's see if I drew this very, very well. C alpha, S is going to be C alpha minus C naught over C alpha minus CL. And then let's just go ahead and fill in this one down here. So R is going to go from C naught to CL. So C naught minus CL. And then the same quantity on the bottom. So let's plug in what these values are and see if I drew this very well. So C alpha, if I go back to the original drawing, is about 42.5. So I didn't draw it so well. It actually looks like it's closer to 48. So I'm going to use this value. And then C naught, we know that to be 40. And then let's see how close I was on CL. So CL looks like it is 31.5 weight percent nickel. So again, I was kind of off on where I drew this, and that's going to happen when I draw this. So I would always recommend going back to the original drawing, and so we get these more precise numbers when you look at that. And so then I just have to plug in those values to here, right? So this is going to be 42.5 minus 40 over 42.5 minus 31.5. And so if I plug all of that in, I'll get back to you on that one. Sorry. So we'll plug this one in, right? And then we'll get our weight fraction. And then same thing for alpha. If we plug that in, we'll get 40 minus, so here 40 minus 31.5 and 42.5 minus 31.5. So let me go ahead and calculate that, and I'll come back and give you those numbers. All right, apologies for that. I had to make sure I had the right numbers calculated there. So let's go ahead and look at CL. So if we calculate this here, so punch it into the calculator, what we get is 0.227. And if we punch this number into the calculator, or we know that the amounts of liquid and alpha have to add up to 1, or the percentages have to equal 100. So we can also just, if we have one of them, we can rearrange, and so we could do 1 minus the other quantity, right? So we can always use that too, but I like to just go ahead and calculate. So in this case, using these values, I get 0.773. So you can also do this just to make sure that they both add up to 1, because if your numbers don't add up to 1, if you only have 2 phases, then you've got a problem. So you can use that as a check on your equations here as well. So we got our weight fractions. So this is liquid and this is alpha. So we were able to determine our weight fractions in this 2-phase field when we had 48% nickel and 1250 degrees Celsius. And so these are our weight fractions. So again, what this is telling us is that if we could sort of magically separate this mixture of liquid and alpha, then 22.7% would be liquid, and then 77.3 weight percent would be alpha. So we can kind of separate those and weigh them. That's kind of what we're doing, and we're going to use this lever rule to get there.